So this is part 3 of radian measure. We've completed converting between degree and radian measures. Today, we'll be focusing on determining the trig ratios of angles in radians and solving a problem involving radians and the trig ratios. So let's look at the first question. Determine the exact values of tan 7 pi over 3, negative 7 pi over 3, and determine the value of cosecant 2 pi over 7. So we want to sketch a diagram of tan negative 7 pi over 3 on the unit circle. So here, I'm going to have a unit circle. Go ahead here. It's my x and this is the y values. So we'll move this for now. Now, negative 7 pi over 3 is more than 2 radians. So if you look at this here, we can break it up into 2 parts to figure out here it is. Or you can just convert it to degrees. We did it with negative, so we're going around. So this is 2 and 1/3. We can convert this as negative 2 and 1/3 pi radians. So here we have 1 pi, 2 pi, and here we have, so if we were to look at this guy here, so this is my negative 7 over 3 pi. Now we need to find that. Now, what is the coterminal? The coterminal is this angle here, which is, now this is 7 pi over 3. So now this is 1/3 pi. So from here, this is, so, but negative 7 pi over 3 is equal to negative 6 pi over 3 minus pi. So we can break it down. Now we have, this is your pi over 3, or 1/3 pi. But this is coterminal with, this would be negative 1/3 or pi over 3, and 5 pi over 3. Now, if you were to go and look at your unit circle, you'll find that, oops, let me write this up properly here. So the terminal point of pi over 3 and or 5 pi over 3 is the coordinates are, now, if you look at 10, so at this point here, our coordinates would be, in a circle here. I want to just show you what I mean by that. Using my unit circle, we have 5 pi over 3 is 1/2 and negative 1/3. Okay. So at this point here now, it will be 1/2 negative 3 over 2. So my coordinate would be 1/2. Now, so that, remember, this is cos and this is sine. So sine of -7 over pi is 1/2. Negative 7/3 pi is 1/2, and -7/3 pi of sine is -√3 over 2. So tan, remember, tan theta is sine over cos, or y over x. So tan -7 pi, oops, you see that? 7 pi over 3 will be equal to sine, which is negative, so we can put here sine of is -√3 over 2, and cos 5 pi over 3 is equal to 1/2. So tan is sine over cos, so we can write that as -√3 over 2 divided by 1/2. Simplify, so tan -7 pi over 3. Now I need to zoom out here. Will be equal to, factor all that, -√3. So go that over. Basically, what you're trying to find, the coterminal arm of -7 pi over 3. Then go to your unit circle to find the coordinates for the coterminal. In this case, it's 5 pi over 3 or -pi over 3. So you should just, so find -pi over 3 and 5 pi over 3. You go to our unit circle and we found that 5 pi over 3, the coordinates, which is 1/2, and -√3 over 2. We know the tangent is sine over cos. We take our sine divided by the cos, and that will give us what tan is. Now, our unit circle didn't give us tan, but what some people have done, they simply worked out all of the tan. So tan would be √3 over 2 over 1/2. And let me show you what I mean by that. So finish it off. So this is your final answer. If you go back to the unit circle that you have in your, to find the tangent for all of these here, you take your sine. For example, tan of pi over 6 or 30 degrees would be 1/2 over √3 over 2. So take your sine over cos gives you a tan. Now, tan 90 degrees doesn't exist because 1 divided by 0 is undefined. Okay. So remember the first coordinate point, the x is like a cos. Think of the alphabet C becoming before S. Now determine the cosecant of 2 pi over 7. Now you have to use your calculator for that. So B, we have cosecant 2 pi over 7. Now I'm going to go to my calculator here. Now cosecant, you can't have that, which is equal to 1. Now cosecant is a reciprocal of sine, right? So sine 2 pi over 7. So I'm going to use my calculator for that. Clear. So 1 divided by sine 2 pi divided by 7. 1.27 or 1.28, which is equal to 1.28 approximately. And make sure you're in radian mode. Make sure, yes, I am in radian mode, so that's correct. So you may want now to try, check your understanding on page 491. So for a practice question, so page 491, question 2. Also, you may want to go to page 497. Number 11. And there's a fair number of parts to that. Okay. So that's your assigned practice questions. Try those. So you may want to check your understanding. That's the practice question number 2 on page 97. Try that. Okay, we'll do one question here that will problem solving question. So here we have, we'll do this part A because we're working in radians. So a center pivot irrigation system traces out, oh, can't see that. Here we go. Okay, sorry about that. A center pivot irrigation system traces out a circular path. So it's just an illustration of this. You might have seen this during the summertime on farmers' fields. And the way of getting these sprinklers, the irrigation system, these are on wheels and they move. A robot control them. So a center pivot irrigation system traces out a circular path and it irrigates farm fields. One system has an arm of 36 meters long. The spread of the arm is 3 meters per minute. The speed of the arm. So that's the speed of it. In radians, through which angle will the arm have rotated after 30 minutes? So let's do a sketch of this problem here. So let's go with just doing A. So sketch a diagram. So here we have, can we have a circle? The center of the circle from here to here is 36 meters. So let's say a starting point is here. So, and it moves now. And after 30 minutes, right, 36 meters, right? We do the angle here. That's what we don't know. That's what we're trying to find. So the arc length is 30 minutes. So starting point is here. And here, position. So after 30 minutes. So it moves. Okay. So here, that's our diagram. The question now is to find theta. Right. So theta, let's theta represent the angle of the arm. So after 30 minutes, oops. So the 30 minutes, we have that theta. Now, the rate, tell us, is 3 meters per minute. So every minutes, right? So it's from here to here. So it roughly will take you, how many, 90 minutes. So 90 meters. So the distance here would be 90 meters, right? So the distance here will be 90 meters. You can see traveling. So distance, which more or less is the arc length, right? It's distance, which is the arc length, is 3 multiplied by 30, which is 90 meters. So it moved, traveled from here to here in 30 minutes, 90 meters. So now we don't know theta. We have our radius is 36, and our arc length is 90. So using our formula, which is using arc, is equal to theta times the radius. The arc length is, so this is our arc. So 90 meters, theta times 36 meters. So theta is equal to 90 divided by 36. So radiant here would be equal to 2.5 radians. So you have, so this angle is 2.5 radians. So basically the arm will have rotated through 2.5 radians. So this would be 2.5 radians. Should be here. Okay. We'll leave part B for now. We'll come back at it later. But all what I want you to focus in on right now is how do you find the angle? At this point, you will want to try number 3, question 3. So practice question. Number 3, part A, on page 492. So now today, we've now completed 2 and 3. So we're one more section on radian measures. So the next lesson we'll be looking at determine angular measure given a terminal point.